Hello everyone. My name is Bankim and I'm having experience of 18 years in manufacturing and industry. I've completed my bachelor's in mechanical engineering, then MBA, master's in engineering and PhD from IIT Delhi. I have worked with industries such as semiconductor, military, solar thin films, aerospace, medical instruments, laser, optics, media storage, stamping, PCBA, SMT lines, fiber optics, electronics, EPC, HVAC, heating and cooling equipment, project management in various roles. I worked from startups to giant as Applied Materials, TDK, and Fabrinet. The most interesting topics I have found commonly in all these industries are the requirement of machining and fabrication. So today my topic is machining and fabrication. Machining sounds a very simple word, machining and fabrication, but it has a whole world in it. We can see all those things discussed during this seminar that I'm going to have in front of you. So this is very useful, actually useful for everyone, including the freshers who have just graduated from the college and they are willing to pursue a career. So machining would be a fantastic option because it is having various roles, such as supply chain, such as the CNC programmer, such as the production guy, quality engineer, a lot. So machining itself is a very big opportunity in itself, and it is like having it can also be useful for those who are willing to have a change in career from some other career because they wish to have, because it's easy to learn as well, but again it needs a skill time tested. So we need if someone willing to have a change in the career and who are interested to look into avenues, the machining would be another one. And then some people who are industrial or entrepreneur, they can also think about it, because this can be a good startup for them, where they can start with 5 or 6 machines and they can make it until the limit they want, like 1000, 1500. The more they implement the machine, the more jobs they can get, and then they can get more revenue out of it. So machining is its term commonly used in manufacturing and industry application. But exactly what does acronym CNC stand for? Do you know? CNC is a computer numerical control machine. Machining. It's a early days, like it was started from the punching of the cards and then to give a command to it, and now it changed to various forms, like designing the CAD model and then converting the CAD model into CNC program and preparing the CNC machine and then executing the machining preparation. So machining operation. So it is like it's a simple thing looks like, but the skill is needed when there is a change in the program because of the tooling wear and tear out, and like over the time frame there is always a play and change in the tooling behavior. So with that, the person or the skill set person need to understand like how much machining program he has to adjust so that he can get the nominal value of the product within the tolerance limit. So all these things I'm going to discuss in this. So let's go over.
Any questions during the presentation, you can type them up in the chat box and I'll bring them out during a question and answer session. And at the end of the webinar, a certificate link will be shared in the chat box. So to receive a valid certificate, please make sure to give the correct credentials. So today we have center for the session on machining and fabrication.
Machining and fabrication, a complete overview and the market scenario of the machining, and how and what are the career scopes in this one, and then basic fundamentals which you might know or might not know, and would be knowing some new terms also today. And there are some machining and the operations, those you already learned and those you may be hearing first time. So I'll also give you some demo and a case study on this one. Like it's a real manufacturing unit. You could see, and then you could have this experience when we walk through the slides, a virtual kind of experience. And then the state of art, like what are the terms and acronyms, and some of the courses you could pursue in going further if you wish to change or wish to make your career. And then again, there are a lot of research topic in materials, as well as in the machining industry and fabrication industry. Those are going on nowadays, and you could, like review back and again. And if you wish to pursue a PhD or somewhere in higher studies, you could do that as well. And there are like I tell you, like in Canada, Australia, US, it's a very big and very huge industry. And as it is like mechanical engineering, as it is one of the a very common thing that is utilized by all kind of industries, almost all kind of industries. So finally, I'll discuss about career path and job opportunities, and then I'll take your questions across. So as you know, machining is one of the acronyms that is used for removing of the material from the material from the raw piece, or some sort of uh, you know uh, material that is come incoming, and then you have to do the process on it and then send it to uh, the final stage where it could be assembled with some sort of assembly or some sort of pre-assembly kind of stuff. So machining do have its a pre-machining process as well as the post-machining process. So those will be discussed in detail come with coming slides. So I'll just read through. Machining is removal of materials from raw materials and getting into any desired shape and size. It varies from a big, like gas turbines or big structures to a small and tiny parts which you could make it and fit it in the mobile phones. Like it's a very big industry. So it depends on which area to choose and which machining center you wish to open or you want to work for. So if you use machines which fed a series of computer coded instruction and perform the same task of machining, it's called CNC machining. It's like computer numerical controlled, or it's a computer controlled machining. The process, the person who performs the task is called machinist. We can also work as a machinist, like a highly qualified machinist in Canada or US, earn as high as like 200 to $300 per hour. And it can also imply like addition of materials that is called as additive machining. If we add on some material, like suppose some part is damaged in the industry, like you're using some molding tool or something, and then you found that the tool is being used or wear off, and it's no more useful, or the tolerances go wide. So you can put some additives with the laser, and then again do the machining and bring it back to the shape. So this way, like the repair and maintenance also takes place in the machine. So I've just given you a little bit of visualization so that you can understand that. I think mechanical engineer or some of the engineers, they already uh, did some of the processing with their lathe machining when they are using. But nowadays it's like no more the basic lathes. Those are used in the industry, but all are using like CNC lathe machine. But anyway, before you learn the high level programming, you have to learn the C or Fortran basic. Similar kind of stuff like we learn the basic in industry, in the colleges or university, and then it comes to a real machining type where you have to understand like in depth of machining cut, feed, or material type, or temperature, pressure, or coolant heat temperature. So those kind of things that come into picture. So if you see that there's a milling one side, on the left hand side, it's a milling. The tool is been cutting up a groove inside, and the right hand side, there is a lathe machine which is used with a combination of tools. Like one is turning and another one is like making slots onto it. So as I said, like this is very big industry. I just talk about which is given by a CHE, or a government organization figure or statistic. It's like the overall CNC machining market is expected to reach by 100 billion, like by 2025. It's about 90 something like that right nowadays. And the statistic says that 7% from 2019 to till it's been growth has been observed. And this is the biggest outsourcing job those are going on nowadays with China, and that is what it makes very difficult for uh, any industry to pull for US to pull out their basic fabrication, because it needs investment, a lot of investment, machines, tools, and the skill set those gain over the year. So these are the reason, like it is very difficult for people to like quickly change their manufacturability from one nation to another nation. It's a strategic, and it needs time, and time tested growth, and it needs a little bit of like investment as well, and the skill set that those are behind, of course. So again, I'll read through the overall CNC machining market is expected to reach by 100 billion, and its statistics says that it's 7% every year. It's been growing up, and this is one of the biggest strength of outsourcing job delegated to Asian markets like China, Malaysia, Thailand. Those are all leading by this thing. By majority by is being in China, like as you know, the Foxconn and all these things, that those are being they are willing to transfer out, but they couldn't because of like trade war. The US want to move out, but they couldn't because of this reason, that those are like heavy machines and equipments, and they really need a real strong capability to do this one. This field is scattered with many small machining house. As I said, like people can start this business with a small one or two machines, with number of machines as much as they want, maybe 100,000, 2,000, 3,000, depends on how big they wish to invest over here. So if we talk about self-reliance and the industries, like they those they want to have more revenue, and or they just want to start from the basic, they could start with machining as well, because machining can be like only machining, or it could be related to the pre-process and post-process. And basically the customer prefers those who have all kind of processes together, so that they do not have to travel from one places to another places. And this is what China is leading with again. Like at one places they have everything called pre-processes and post-process. This pre-process and post-processes I'm going to discuss with you in coming slides. So as machining house, it could be started with as low as single machining, and could be increased to thousands or 2,000s or 5,000s. Some have like maybe 10,000s above. So it depends on the industry or the investment sector they wish to have. So those people who are joined here as a business consultant, or they wish to have more business, like to be increased, or a unit that they wish to open as a secondary or capillary unit to their industry, they can use this as one of them, like on side by side, and you'll see that the revenue would be worth investment, because the ROI would be very quick, and it would be like very like substantial growth you will be observing coming days. So I'll just a little bit give you a market overview about there. As I said, like this is a kind of a multidisciplinary uh, branch where every industry need this as a tool to make something or the other thing in their organization, such as like automotive. Yeah, of course, like automotive is a standard fixed line unit. If you see if you can understand, automotive is like one car, one model is like thousands and thousands and thousands. So those thousands or 10,000s they make in one time in one set. It's a one line. They fix the line in this one. So they fix the machine lines as well in that one. They do not have much flexibility, because the designs are not changing very frequently. Those are like added with the automation and robotics, and reduction in man assistant manufacturing, and the lines are totally like dependent on the automation. They could be remotely operated as well. Those things also I will discuss. And medical are like medical instruments are that, especially like those are instruments used to detect the blood analysis, or nowadays they are using for, some of the devices. Those can detect the viruses as well. So those are all need machinings backend. So if you talk about machining and fabrication, every part or every unit in the world uses one or two items of machinings uh, in it, machining and fabrication in it. So you could understand the magnitude of this industry, like how important this industry in the world. And this is the reason, like during even this COVID, post-COVID era, this industry is still growing because like business comes up or down, but some industry like IT sector maybe grow up or down, but machining is always a demand because just like food or textile, those never been in like low demand, but it's always been required by people like that, like medical, sorry, the machining, it's been always utilized, always required by. So if you see that automotive is the highest and the biggest factor in the machining requirement, they have loads of like in every country like Europe, US, Canada, Australia, they always need this kind of, and that is the reason they always looking for secondary unit or two-tier suppliers where they can have their jobs to be done in cheaper mode, and the shipment and inventory could be reviewed out at those. So being nowadays is like India is one of the cheapest or one of the competitive market in the world because of labor, of course the skilled labor, I can say that. And second thing is the resources or the materials, because it has its internal materials control system. So that is the reason, one of the, like it is a growing, and it could be, if it could be adapted in India, it could be a major boom in the market. Of course, then aerospace is there, which is down nowadays because if you see that all the airlines has been held and stopped. So the demands, whatever there, it's all on hold. So, but again, it's a machining industry, so you can use those machines for medical or automotive or electronics sector, because electronics sector is still, it's a growing thing. It's not going down yet. And then semiconductor is there. In this semiconductors, you have different thin films or TFTs, or you can say that solar manufacturings are there. Those are all semiconductors. You could again use the equipment and machines. Those need the machining parts in it. Industrial, such as industrial system equipment, those are required to deliver. Suppose like industrial, maybe you can say that heating equipment, boiler, or maybe the uh, conveyors, automated systems. Those are all industrial kind of stuff. So like that, laser is one of them. Now we'll say that laser is totally optics and something like that related to electronics. But the base of the laser equipment is of machining item, which is casted and then machined, and then afterwards also the laser which are used for lidar or could be used for medical devices are also one of the major uh, like industry nowadays. Emerging markets are also, of course, like IoTs. Those are like Internet of Things, or some of them are like service sectors. That could be applications are huge and wide, as you can see that. And then if you see that automotive is one of them. Right now still is the big, because automotive demand is still changing from one sector to another sector. Earlier it was with the uh, like petrol or LPG or NGV, but now it's going to all electrical vehicles. So again, it's coming up with electronic and electrical vehicles. So EVs would be the next. So if you see the major machine providers, if you are willing to have Haas automation, most of the industries are using this. Urko, it's from Japan, Makino, Okuma, SMTCL. I'm not anyone's like, I'm not selling agent, but just telling you that these are some of the major machine providers. Types of machining requirements based on demand. Like if you see that again, lathe machines are there, like based on the processes. There are various kind of processes for the machines are there, like lathe machines, milling machines, laser machines, grinding machines, welding machines, EDM, progressive, broaching. really. So I'll just give an overview because I will not, like go in depth of this machining types. But lathe machine is one of them, which you have already saw, like with the circular motion, and the cut tools are there. And then milling machines are like a circular tool, and the workpiece at the base, and then it cuts around the base and the complex structure. So milling machines are various kind of machines, like 3 axis, 4 axis, a 5 axis. It's a standard 3 axis, 4 axis, and 5 axis, but it could be increased up to 10x. That means the level of angularity and the positioning of the tool that need to be cut and approach towards the workpiece, it's called the axis. So which way the cutting process is going through. Suppose the process is going through X, Y, and Z. So it would be like 3 axis machines. It's clear right now. So these are all kind of axis system they are used. So the reason why multiple axis is there, because if your part is needs like one setup and machining with one setup, you need those kind of multi-axis, and you do not want to even like deter it by 2 microns or 3 microns. You just wish to have the similar kind of angular whatever is given in the drawing. So that is the reason of strict like one setup. uh, Multiple axes, more than 5 axes are required sometimes to have more precise work. Because when you talk about stack up tolerances and GD&T, so it's related to that. Like when, because in machining, you do, if you know about machining, you do it by referencing from one axis to another axis, referencing from datum to another point. So it's like all about referencing. So uh, give me a second, I'm getting some chat. Everyone, can you hear me? Because someone is saying that, sir, I cannot hear your voice.
John, yes, we can hear you.
Okay,
Just
something
a
like
minute. Give me 1 minute.
some Arul Sridhar,
Yeah,
he's pinging me that, sir, I
I
cannot hear
think
you.
I'll check with them. You can just continue the session.
Okay, all right. So, okay, so the axes are all related to one of the datum or one of the axis. So if you move the workpiece, then because every machine, even the new machines, they have a play. Like play, you already know all over. Like whenever you are doing some assembly, there is a play with everything. So that play is called like the tolerance. So that tolerance is the thing that is very very important in doing a high precise machining. So this tolerance, when you try to do it with milling machines with single setup, it would be with the less impact, because the referencing would be very correct, because all the tools are not referencing to the machines now or the workpiece side, but it will be fixed with a proper axis. I think you got it now. So this is how the axis really depends on the accuracy and one setup. And also it reduces the cycle time of the machine, but the machine price are very high in this regard. So what happens is that when the machine price is high, people are trying to put some more cycle time on that one. So over the time frame, the 5 axis or more are cheaper. But at initial stages, the price are very really high for 5 axis or more. Then we have laser machines. Laser is one of the favorite tool nowadays, going on with a lot of industries. Laser cutting, laser welding, laser joining process, or with laser detecting something and then giving the feedback, just like the optical fiber. So laser is having a wide range of usage. So if you see the laser machining is one of them. When we use the high frequency, it has like a very high cutting rate. Like when it goes with stronger heat generation process, it can cut the metal very quickly. But the problem with this is that the laser puts some sort of burning mark on the place. So burning process makes it like more corrosion kind of, it exposes to the corrosion. So we have to do a after treatment process for that. if it is needed. But if it is just a cover kind of stuff, no need to have that thing. But if it is really needed in some sort of where there is a exposure of material is there, we need to have this kind of like secondary process enable to make it noble or non-reactive to the circumstances. Then there are grinding machines, like you already know grinding machines. But grinding machines are also many kind of grinding machines. Like depending of 1 micron, it's really like like 16 micron is the hair diameter. You can think about 1 micron, how small it would be. So it's like very, 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 very thin, very, very small, and those kind of surface finish is required. Surface finish in terms of roughness, or also in terms of parallelism, or in terms those who already know GD&T, those are like they know already like what is surface finish and what is roughness texture. So it needs like it goes until like 1 micron for grinding. It's moreover used in optical industries, laser industries, where the surface finish really matters, because when it comes to the light has a different angle of incidence when it strike to some body and go up. So it has a varying angle. So if the surface finish is not up to the mark, then there may be a possibility of refraction, a different view, and then the object may not work. So you understand that is really very complicated process, and it comes with optical grinding, it comes with sand grinding, it comes with slurry grinding, it comes with alumina grinding. A lot of grinding itself is a big, really challenging uh, career. Some people I saw, they are only grinders. They don't do anything other than grinding. Then there is a welding machine. Welding are like a very common term. Welding, like welding, TIG, MIG, spark welding, butt, or sort of like different kind of weldings are there where you can join two parts. But depends on, again, it depends on welding, how accurate you need the parts to be joined. Suppose you need more accuracy, you need to give it like more TIG welding on that one. So that again use variant use from a small industry to a big industry like the piping industry or the gas industry or turbine industry, where the welding is very, very common and very widely used. The more accurate it is, more precise it is, more skill is required in that one over there. So some people are called a certified welder. There are quite a number of certification in the welding process out there. Then there is an EDM, like electric discharge machines. These are like spark created machines. It creates the spark through the machine, and then it removes the material under one solvent or slurry. And then you can see a nice surface finish on that one. And also it exposes the material. So it need to be have after treatment process. So I'll just go quickly, like a progressive die is there. Like it's a stamping process. In this one, different kind of stamping is there. I'll give an example. Like you have a mobile cover. So this mobile cover example, it's not coming with one step. If you can see that the mobile cover has like 5 or 6 steps is there. One is like a flat one, then it curved to some die, and then it cut from the bottom and the side. So it has not going through one process. One is like it going through different stages of process of cutting in the stamping. That's called like a progressive die. Broaching is a wider term, and it has like a low accurate machining process where the broaching tool is there, a big one, and then it cuts material in a volume. Like you have very quick cutting of the part. Drilling is of course one of them. Like everyone is know it's used as one of the tool to drill the hole and remove the material from the part. So I think it's real quick overview, and you see that the machines those are used in the field in the CNC machine market. Uh, those are like lathe machines, and those are like milling machines. So these are the two most commonly used, and it's a business of about nowadays it's about uh, 20 billion dollar. So again, it's again another industry where you can work as an automation engineer as well as a tooling engineer to assemble and make a tool. Sometime These machines are also customized machines. Example, like some of the uh, clients, they need this machine tool according to their requirement and the site available. So they say the person to design it, because the PLC is the same, like the program logic controller, that's the same, and the tools and the sliding arrangement, the lead screw, the belt arrangement could be done based on the designing part. So a customized CNC is very common also, and it's a very big business as well. So if you wish to pursue in that CNC only, customized CNC, there is a business as well in that one. Okay, so I'm just showing you a bit of example of milling machine, workpiece and process. So if you see milling machine, the first is like very simple kind of facing. It's a spacing operation when milling tool is being kept on the product, and the products are cut through with the help of tool, and you can make it grooving, or can make it with uh, removing of material called facing, just plain facing, or maybe drilling or slot or counterbore. Different process and functionalities are there you can use with that. Those are like simple machining, because some parts just need a simple machining. So what happened is that some machining center, they are earning just with simple machining process. They get the orders, and they put the parts under their table, on the workpiece table, and just buy the tool and plainly do a simple machining. They don't want to explore a complex machining. Complex machining kind of like you are making the part in a different axis. Like you see the second one, it's a medium kind of, it's a pocketing inside one part. If you see that, so pocketing, it's when you have to use a CNC programming which have a dwell time, as well as have a datum to refer, as well as it has a depth to refer, and the cut feed rate it could. So it's a medium complex. It's not a complex, but the complex one is the last one. You could see that. So I'm showing you the Haas CNC machining, where different tools are put it on the card, right on the left side. If you see the round, this is the tool that machine can automatically pick up based on the the required cutting process we need. So in one machining, we can use drills, we can use the mill, you can use the cutting process, or you can use the round or turning process in one machine only. So this is how, like, and then the right hand side you see the control panel. So in the control panel, you normally you can do the programming with the help of Mastercam, and using the SolidWorks. Example, like you make the part first, and then design the part, or import the part in the SolidWorks, and then if you want to modify something or modify, or you want to give some command on tolerancing or a GD&T stuff you want to see, and you want to check, and then go it with the Mastercam. So in the Mastercam, or also SolidWorks nowadays, it's also have this kind of features. So in Mastercam, you can literally see the tooling, how which tool where it will be used, and what is the cycle time that will be needed to manufacture the part. So this is how you first develop, and then you just put the save as a program, and then it will give you automatically program from the machine. So this program, you save it in the USB drive, and you put this USB drive simply in this uh, uh, in the machine, and then the product can be like made. Okay, now where the skill comes in this is, because your tool and your machine has a play. Okay, so after some time, your tool and machine wears out, or it has some changes. So with the changing tool, or changing time of the process is being done, you need to come back again and check that if there is some differences in the part, when the parts are very precise, there is a problem or not. Because if you give it, okay, it will make somehow like maybe 500 pieces or 600 pieces one time, but after that you have to come back, because if you don't come back, then maybe the parts are already damaged, maybe 200 pieces. So you need to keep running on that. That's where the skill counts. Like, what is the thing that you need to adjust, or based on the time frame, and when you have to replace the tool to minimize the scrap and the wastage of the material. So if you see, there are 5-axis complex machining. This machining, if you see that one axis is the tool that is cutting up with the angle, another one is the tool itself is moving out on making a different groove, and the groove is like angular as well as it has doing some facing in it. So 5 different axes are used in this one. If you clearly see 1, 2, 3, 4, 5. So this is how like your 5-axis complexity parts are there, and depend on the machining requirement, we go with this. So overall, if you see that type of operations we can use, we have already discussed a bit, like milling, spacing, as you saw just a previous slide. And there is a peripheral milling is like the milling that would be done on the side of the part. The part is already came as a solid material, which inside is already machined, but outside you have to do. And there are like a facing operation is there in the milling, pocketing is there, pocketing and creating the grooves and shells inside the material. And then the turning operation is there. Turning is in the lathe, you can use the turning, or also in the milling you can do turning, but lathe would be good because, see, depend on the operation, mm, you have to keep doing that process. Keep changing the process, think of the process. So here it is. Example, like one part, you're making it everything in the milling machine, and it needs a uh, turning operation, and you're doing it in the milling machine. What will happen is that in milling machine it can do the turning, but then what will happen is that in turning, it has to do the tool to be round of the part, cut through all the sides and do that one. So what happen is that the cycle time will be more. Those things you can do in lathe machine in very low cycle time. So you can save the cycle time. Why I'm talking about cycle time is that cycle time is a cost, because the more you run the machine, the more it needs the time of the industry. It relates with the cost of electricity, cost of running cost, like all kind of cost, lubrication, maintenance, and the manpower, man hour, everything is including in that one. So automatically your price cost increase if you don't define in a proper way of a process. Because if you use one machine for everything, and suppose that operation is not effective, then you have to like run it with a higher cycle time, and ultimately you cannot compete it with the other competitors, because the other competitor already knew the the niche, the best of the machine, and then he will use a different combination to reduce the cycle time, and he'll get more. He can make more in the same time, and he can give like with the less scrap rate. Scrap rate is what, like if you use a big material and then you cut very big material out of it, and you just have very small machine or the final product out of it, so you're wasting like about 50 to 60% of material out of that part. That is like your scrap. And also scrap is one of them, is like when you make the part and it get waste because of setting time, because of your person is not skilled, they don't know how to set up. So it will be like again, one by one, it will go again to uh, the higher cycle time rate. So what will happen is that your scrap rate is increased, your product price is automatically increased, right? So you have to buy more material for your machining house. Again, there is a boring, sorry about that, boring machine is there, and boring is a kind of drilling machine where you use a bigger tool to remove a bigger chunk of material. Reaming is the process, like after drilling you have to do a small amount of material to be removed with the precise in shape in the same area, like repetition. Drilling is the bigger. So if you rate it like drilling, boring, and reaming, you'll first boring and will do the drilling and then we'll do the reaming. Like likewise, like very precise it's reaming, and the very non-precise is very big tolerance is boring. Broaching operation is like a kind of sawing operation only, but it's a bigger removal of material. Shaping is also one of them, like where you can cut the slots. I think shaping machine everyone has used in their engineering days. Planing machine is one of them as well, like a milling machine. Then there is a operation like additional operations that like you will be coming through if you're pursuing this career, like casting, extrusion, metal injection molding, forging, coal forging, boring, reaming operation. These are like some of the operations which you need to do before pre-process to have the material to like come through the primary process, that's called machining, and there is a post process also. So types of machine we used in industry. These are like some of them, like lathe machines, milling machine, laser machine, grinding machine, welding machine. I guess like you already knew all this thing, but EDM is the one that is not that much known by the people. EDM and then EBM. EBM is one of them, like a high velocity electron that is concentrated into a narrow beam towards one workpiece. So what happened is that the beam is being just like a plasma. You can think like it's being like forced through the nozzle, and then it gives a definite shape uh, with the sort of the electron pulse in that material. So this is how the material has been removed. Ultrasonic machine is machining that has been done with the frequency of the material, like it removes with the sound waves. Abrasive jet machining is there, like uh, you use a high velocity jet. That means a water soluble. Means you dissolve some sort of abrasive material in the solvent, and then put it through the nozzle to cut the workpiece. Laser marking, this is very common and it is very needed in all sort of industry. Like you if you want to write something on the workpiece, and that work, we normally use the punch, but we don't want to use the punch because it's not very accurate method. But laser gives a nice smooth texture of the letters that you'd like to engrave in the part. That's called laser marking. Laser cutting is, of course, like we already discussed, swedging machine. It's a kind of forging machine, like used in the bullet industry. Like when you have a part, you force it through the die set, and you bring out some, uh, round shape or square shape or some sort of X shape, whatever shape you like to have, and in a very mass production. It's like ongoing process. Material is being taken into a sort of cylinder and then push it through one side through the die set, and it comes out with one shape, and then you slice it like uh, any kind of carrot or something. It will give the same kind of shape when you use it. Like the bullet machines, you use a small part, and then you uh, cut it through a round shape, and then that could be make as a cap of the bullet. So then there is abrasive jet machining. It's like I already told at the beginning. Similar to it is a water jet machining. Water jet machining is the less abrasive we use, and then more water contents in that one. Then chemical etching is there, like etching. You already know cathode anode kind of stuff, right? So it's a chemistry, you have already learned that one. So chemical etching is one of them. Like you use the cathode anode on one part, and then you put the electricity to remove the material through that process. Then progressive die is there. I'll just switch the swedging because we already discussed that. Progressive dies is there. We already discussed, like it's a stamping part, like when you use different stages of stamping process to make one part. I give you example of the, the mobile cover recently. That is kind of broaching, drilling, boring, pole threading. Uh, Again, there are few specialized machines are there which can only do the threading process. Because when we talk about hardware, like many hardwares are there, like thousands and thousands, millions of hardwares are being made and being utilized. So those hardwares, we have to make through the bolt threading process. So it uses specialized machine, or we can use definitely lathe, but lathe would be very expensive. So normally the bolt threading process is there. Uh, then the gear hobbing process. Gear hobbing, again, it needs a special machine. It could be made through the milling machine as well, but again, it's a cost factor. So milling machine will take more time because it needs a mm, 5x machine. But then if you use the gear hobbing machine, it's just a matter of time, and it could be easily made through that gear hobbing process. Cold press is a forging kind of process, like where the material is forced from the die set when it is cold. So some processes need that because they wish to have similar kind of part without being distorted through the heat factor. So they just want to push it through in a cold manner so that the material properties should be same. So again, fabrication process, progressive die, you already knew it, and sheet press, uh, like laser machines you can use, or you can use the sheet press to cut the sheet through a different die set you made it. So that is called sheet press. Like laser, you use the laser to cut some sort of stencil you wish to have. Like you can imagine the computer box you use the CPU of the computer. CPU of the computer itself is made up of a stamping process and the laser sheet cut process. Like they first made it a flat and then they bend it, and then they have grooves and holes. You can made it through laser punch as well. Like it's a very easy process, and then it is available to everyone. Bending machines, again, if you wish to have a thicker material, uh, you normally use a bending machines where you can use different sort of support structures. Uh, the material, if it is very thick, like thicker than maybe uh, 1 10 mm, 20 mm, or maybe more than that, you can use the bending machines to bend it. Power press are there. Again, similar kind of machines. Those are used to uh, punch and cut and bend. And then the riveting machines are there, which fix the rivet on the parts. Like if you see your again in your computer nearby uh, electronic device, you could see that riveting is done on the part without any screws or anything, because they just want to save the cost of screw. They just use the rivet and then fix it together, just to save the time as well of fixing. Joining process I discussed with you in the last, that is welding, arc welding, TIG, MIG, tungsten electrode, inert gas welding, and then laser cuttings, butt welding, turret machines, arc welding, oxyacetylene welding, soldering, brazing. These are all the processes that are being used in the industry widely to make the part when we make the assemblies. So I think we have a bit of picture now. What are the processes we should be knowing when we talk about machining and fabrication? Because it's not only a machine that makes some part, but it is also related pre-process and post-processes part. So pre-processes are like castings and uh, uh, extrusions, MIM, all other things. And post process is there for example, platings, coatings, powder coatings. So those are post processes. So pre processes and post process, both are there. That is related to the machining. So this is how it looks like to any kind of industry. It is applicable. It starts with the receiving of the drawings. Example, we receive the drawing from the customer that they need to produce a component. Suppose you take an example of a shaft, or you take an example of the bearing sleeve. Like it's an internal hole is there and an external. So external, they have to make it's a round in shape. which has some diameters on it, an external and internal diameters on it. So this this thing has to be fed through the drawings, and the drawing has the standard, because those people who are making the drawings, they have to go through their certification on understanding the NC codes, ASCII codes, and the drafting codes, because once they have to make the drawing, they should know how to represent this machining specs so that the other machining guy can understand easily what they're talking about. Because you cannot say in the writing that please cut 20 diameter on this part. No, cannot. You just have to show it by a diametric symbol that is being understand and read through the GD&T process. Like if you search GD&T process is one of the very widely used everywhere. And it's, again, you have to learn mill standard, GD&T standard, NC, ASME standard. These are all the standards that you need to learn to understand the drawing reviewing process. So once you learn the drawing, like how to read the drawing, it's one of the very, very important factors. When you would like to have a machining house, you should know how to read through the drawings. So once you read the drawing, you understand that okay, this is the pre-processes that is needed. Because if the part is having like higher volume, then you need to go through the pre-processes process. Example like casting, you can use a die set, just pour the material, and then you got the material out, and then you do the post-processor machining, and then you send it for anodizing, coating, or whatever you'd like to do the secondary process, and you get a part. I'll just give you a nice example of you. Like you can see the example, pen. Okay, pen you have. So in the pen example, you'd like to have a pen which is very nicely made at the Parker, like example Parker or some very branded company. So they will do pre-processes as uh, like uh, the a pipe. They will use a pipe, or they will use a forging process to make it like a hollow, and then they will cut it into pipes. Like swedging also they can do, but they can use a process, forging or swedging, so that they can get a hole ready-made in their part, because inside hole doesn't matter, but still it needs accuracy. So they will have the outer surface finish, which need to be a mirror finish, and then the plating should be anodized or something. So you understand. So and in between they have to do the lathe machine turning so that they can get a very nice external surface finish on the part. So this is one of the example where you have to receive the drawing and then feed back to the customer. Again, it's a process where you have to DFM back customer, like design for manufacturability. See, what happens is that the designer always wants a part to be very high accuracy. Example, like they want to have like 1 micron, 2 micron on everything, or they would just want a basic dimension for any part. But then basic dimension doesn't work everywhere. They need to have a tolerance because of manufacturability. But again, tolerance in what level? Because the designer wants everything to be standard or basic, they do not have a tolerance kind of stuff. So the tolerance they provide is very low, but then very low tolerance comes with high price, high precision. So they have to think that, okay, they have to discuss with the customer that if you need this, this is the price, but if you don't need this, really don't need it, because internal diameter of the pen barrel is not needed that much, because you just put the ink in it. So there is no problem in that one if you keep it like 10 microns and up. But then if you outside, you want to make a higher surface finish, you have to go through a number of cycle of polishing, and then painting and external, machining kind of stuff. So those things are understood and discussed in a DFM process, and then feedback to the customer. And the customer comes up, okay, then fine. So our target price is this one. Can you do this one? So uh, then the manufacturer person, whoever is there, they have to say, okay, we can do that, but then you have to relax some of the tolerances. So then quotation goes to the customer, and customer say that still we need some rooms on the one, or sometimes they want like a yearly reduction of the price, like automotive sector. Normally they want a reduction in the price. So they go through the negotiation process that, okay, fine, no problem. We'll not do anything in this year, but next year you have to give us like 5% cost reduction. The cost reduction based on what you have to understand. The machining house has to understand the process one more time in a year to make it lower price for them. That's called negotiation, or maybe negotiation at front also. They say that, oh, we cannot pay this much. We have this much of budget for our product, final product. So your component should be this much. Then only we can work out. So then machining house has to come back with a solution on that. So then customer order received after that, and then after they receive the customer example, I'll just give the same example like barrel, and then they put it through the incoming material. Incoming material would be the in process, that is after forging process, or uh, cold forging, or swaging, whatever you'd like to have. So that process, it comes in, and then you check the outer diameter and the length of the part, and then you put it for the lathe machine. So lathe machining, you do the lathe machining process, and once you finish that lathe machine, then you send it for like IQ is like incoming inspection of raw material, incoming process. It's like incoming quality control. So in this one, then if you have a feedback, oh, raw material is not good, so you have to go for rejection. Then you have to go for, if it is okay, then you go for manufacturing of parts. In manufacturing, again, if you use a tool which is very like gone, or worn out, then you have to have scrap those parts, because they cannot attain the tolerance that is required by the customer. Then it comes to the feedback to the IPQs, like in-process quality control check. So it's in-process quality control. Again, the feedback, it's been given, the raw material is okay, but in process they have some defect. So they will ask engineer to come and then sort it out, and then send it back to the or scrap it. So the two-way only. Either they have to go back and pre-process again, means in process again, or they have to scrap it. If they can save the material, they will save. Otherwise, they will scrap it. Then it comes to the OQA, that is outgoing quality control. So in this one, like they will see the final dimensions or critical dimensions are all met, and as per the spec that has been given in the drawing, and then they will pack for it. Packaging in another industry, like complete, because they need carton boxes. The carton boxes need to be cut down at piece, so they have to bring this all packing material, packaging material, the sponge, the foams, the plastics, how they have to ship. This is all given in the drawing itself. Then they pack it and then send it. But before that, suppose they want to do the post process. Again, they have to send it to the secondary supplier, because one machining house may not be having the plating facility like anodizing or gold plating or something that they need to have. So they have to send it outside, and then again the outside people will send as per their certificate. They can check those items in their product, and they can use that as that, like outgoing quality control check. And if that is okay, they can ship it from there. All right, so this is like we already discussed about pre-processes and post-process, like casting. Casting is use die set, and in the die set you have to pour the material, the molten material. You have to heat it in the furnace crucible. Different material has a different molten melting in like temperature. Like aluminum is having like 1500 degree, 1200, means 1200 degree. So those temperature, it got melts, and then they pour it in the casting, and once in the mold. So again, mold preparation is another engineering technique. It's called tooling manufacturing. So they have to design the gates, screws, and the channel through which the material, if pour inside the casting area, it should not freeze somewhere, it should not stuck somewhere, or it should not give a pocket somewhere. So they have to be very careful in designing this casting mold. So after this casting, they have to send it to, again, the machining or cutting or trimming process. Then there's extrusion. Extrusion is it's a kind of forging only, but extrusion is a little complex, because it has a higher accuracy other than the forging. Because in this one, they use normally the aluminum, and they make the heat sinks or kind of X bars used, or the rail bars. You can see your curtains, those are made up of the rods, right? Those are all made up of like um, extrusion. You can see your window also, sliding window door. with the aluminum frames. Those are all made of extrusion. So forging is a similar process. Cold press, cold press uses the cold material. Hot press use the hot material as their raw material. MIM is metal injection molding. So the difference between the metal injection molding and casting is that casting you use ingot. Ingot is a big material, and in MIM use the small particle of the part. You put the particle inside the die, and then you heat that die. That's a metal injection molding. Or you can put the small very small like grains of the part, the material, and then pour it inside. Then cutting is there, sawing is there. These are all the pre-process. Cutting and sawing, it's like a sawing example, like you use the saw, normal saw to cut the big part or the pipe or something that you want to use in the next process, and then send it to the production. Post process like surface finishing are there, different kind of surface finishing like plating, anodizing, drilling, shot pinning, sandblasting, tumbling. Tumbling is it's a barrel where you put the part along with the media and then close the box, and then you rotate it to 2 hour, 3 hour to make it like more smoother surface and remove the burrs, remove any surface defects sometime. So those are also called deburring process. And deburring is again, you can use it by hand also, but you can use the tumbler also to make it more like deburr without touching them. So you can send like together one lot of material and make it and bring it. Other things are you already know. I think surface finishing like plating. It's like you use the again cathode anode kind of stuff. It's same as the anodizing. And plating is also like you can use the paints and just dip it in the paint. That's also you can do. Drilling is there. Shot pinning is there. Shot pinning and sandblasting. It's like you can use the small part of bowls or the media called glass or steel or plastics, and you force it on a material to deburr it or make it smooth or make it some sort of material texture you want to give it. So those kind of things are post processes. And then you use the ultrasonic cleaning. Ultrasonic cleaning, you just have to use a vibration to like inside a bathtub of hydrocarbons, and then you can remove the burrs and debris from it, whatever you do it during the cycling process, like in the machining process when you do the machining, and after the machining you have to remove all the debris and everything. So that is how you have to use this ultrasonic cleaning. I'm just walking through some of the very interesting machining center. Like this is real machining house where you can see the auto lathe bar. This is with a big one where you saw the revolver, right? So you put uh, the bullets in the cartwright. So similar to like this, they put these bars, long bars inside this cartwright, and then one by one they feed it inside the machine, and then the machine for sleeves or some sort of bearing outside, the outside shell. These are all happening auto lathe bar. And chucker machine is there, like the small. It's a it is like automated, but in this one, like you put one part inside the lathe with already programmed, and it will complete the process and then give it the finished part to you without you being touching it on it. Just you have to open the door and close the door. The rest, the programming will follow. And bar capacity, like this is like kind of long bar, you can use it. And this is the chucker, you can use it. The investment is about like 3 lakhs to 5 lakhs based on the new machines or the used machines you want to have. Used machines are also very commonly available in Asia Pacific. You can contact to Japan because Japan has a policy that they want to scrap their household items and they pay for it. Example like if you buy a television there and you don't want to use the television anymore, you cannot just dump it on the road or sell it to anyone. You have to pay for the scrap charges to the community center over there. So That means everything you want to scrap, you have to pay for it. So the machines are really cheap, which is used already, because anyway they have to throw it. So if you want to buy it, they will just ask you for shipping charges if you're lucky. So that way, some people already started in Malaysia or in Vietnam or Cambodia. They have already started this kind of, like, because their trades are open, means uh, they can import anything directly like that, and they can use that part because the customs are not very, very open and very, like less in that one. So they can easily buy from them and then they can start machining house right away. Similar to this one, like second, the CNC milling machine. If you see that milling machines are there, uh, there are like, as I talked about the milling machines, they are, uh, there are doors are there here. You can see that the doors are here. You have to just open. Once you set the programs, you set everything over here. You can just insert the raw material inside the door and close it and wait for happen. One person can at least operate 4 to 5 machines if the cycle times are set like one after another consecutively. So you just put this one here, and then another one is here. This is already finished, and then now go here, then go there. Like one by one, you can manage, like one operator can manage. For this way, the industries are doing it. Like one operator, they manage because the operator is just to install, unload, and load the part. The rest the machine is doing, CNC machining is doing. So your manpower is drastically reduced here. So you no need to be using the similar kind of method like you use in the college days, using a tool, and then you do the machining by hand. Those are all the day. Those are gone. Like here, no one is using those kind of things nowadays. So in the next, if you see stamping machines, you see a lot of stamping machines side by side. They are over here right now, and they are all using progressive die or some sort of mm, not non-progressive also, like fixed line stamping center is also there, or specialized stamping machines are also there which do only one function. So if you see that there are like 3 to 25 lakhs of investment, depends on the tonnage of the machines you want. Normally the stamping machines are defined by ton, like 10 tons, 50 tons, 100 tons, 150 tons, 300 tons, like that. That depends on the tons required to bend and shape the part. So machine center uses like a wire cut machines. If you can see that there are different kind of wire cut is one of the also process of machining where you, when you need a very slow process and very high precise accuracy, like the tool also you want to cut sometime. The tools you can use like wire cut. So wire cut is very high precise, and then use the laser mark. The laser mark uh, to make sure that you have a proper nomenclature of the product. So you want to make it very nicely and evenly, so that it could be visible and readable at every circumstances. And then microlapping is there. Microlapping or super drill, those are like very, very small, fine drills, about 1 to 5 microns. It's and the depth is also very high. Used in moreover like medical industry, where you want to use some samples and then pass the samples through that small capillary. Laser weldings are also there, which we are using for high you know volume of parts where you want to have a welding, most like a small kind of parts also you can do it, laser welding, where a few components you can weld it and use it in electronic industries. Grinding machines, you can see that there are various kind of grinding machines are there. Double disc grinder, it means like on the top side and bottom side, both side you grind one part. That means together you decide the flatness and the thickness and the parallelism of the part along with the surface roughness. And then double disc grinder horizontal, suppose the parts you want to make it like horizontal in place. So you can use the horizontal grinder because there is a base over there. So you want to make it a horizontal. So you can use this one. Centerless grinding it there. You have like 3 or 4 rolls are there. Inside that roll, you're putting one grinder and then you will just roll it. There is no grinding, but there will be equal pressure on the one, so that the sizes come out of it would be like exactly as required. Similar to surface grinder, like this one is very common. You can use it CNC and non-CNC both. Investment amount is 2 lakhs to 20 lakhs. These are some of the stamping parts you can see along with the uh, grinding process on it. So you see the surface structure. They are like the hairline surface structure. Suppose some people wants to have this kind of hairline, horizontal. Someone wants like vertical, kind of hairline texture. Depends on the requirement. Surface texture is also very important. Someone needs shiny, someone like glossy, kind of. Then automotive business are there like related to the crankshaft or the engine body or the two-stroke engines. You see this one are like engine cover parts, and so these are again threading operation is needed. You can do a casting and then threading, and then for barreling or tumbling, and then you can just send it to them. Laser component parts are also there. You can use it like different laser components in this one, where uh, you can machine this part with different kind of axis, like 5 axis or 6 axis, and then you can create a different kind of channels through it. So these are some of the example, and then you can assembly kind of part, and then get gold plating, and then send this part. These are kind of some part like which you can use for telecommunication industries. Telecommunications such as like 4G, 5G installment. Uh, so those people need this kind of instruments. This is biological analysis machine. Some of them, if you can see this one, like you put some blood over here, and then it will give you a complete report once you put a program on this one. Like, okay, this is the guy name, and then it will give you DNA. It will give you blood sample analysis, everything. So some of the parts used in these materials are you look like black, but it's not metal. It's a plastic. It's a very like 40% plastic and 60% glass in this one. So it's like all 10. You can see that one. Those are like highly precise. Sometimes you want to use some parts which are very non-reactive. You do not want to use metals over there, because if you use the metals, then it may react with that. So you want to use strong as it is needed, but also non-reactive. Automobile parts, you can see different areas. There are hundreds of automobile parts. Those are like 2 tires, 3 tires. We can use any. 2 tires means like you have a supplier like Toyota or Honda. They have a supplier. Those needs like definitely 16949 IATF, but then those needs a heavy investment. So what we need is like someone who can supply to us, because supplier also need a secondary supplier. Some suppliers are doing like this. They have a machining industry, but they are unable to make it more you know cost effective, so that they give it to the secondary supplier. That's called second tier supplier. But second tier supplier, not related to Toyota, but Toyota don't know them, but these people know them, that they can do it. But because of certification and all those requirements, they cannot come to Toyota and they say that, hey, we want to be your supplier. So Toyota or Honda, they have their own sort of audit requirement that is a very complex and very high in standard. Some of the automation system, machining parts in the aerospace and aviation sector. You can see that in nose landing gear, engine parts, main landing gear, kits assembly, actuation system, everywhere machining parts are there. So this one, like they use normally coal forging, die casting, aluminum extrusion as a pre-process. Heat treatment. Heat treatment is like hardening, tempering. Heat treatment are given to change the granular structure, give the hardness, the required hardness to the part, stress reliever or softening the part, annealing, case hardening, soft nitriding. These are all kind of heat treatment machining industries. Okay. Surface treatment are like iron plating, zinc plating, chrome plating, gold plating, silver plating, acid aging, hard anodizing, clear or black anodizing. You see the material. the kind of material that industries are using. Aluminiums, this many 6061 to Mi6, stainless steels, SUS 301 to Cold War, in war, titanium grade. These are all machinable items. I think you might not heard about many of them, but these are the industry. These are the parts. These are the materials used for the parts in industry. So example like aluminum, like very soft and ductile, easy to machine, but steels are like very hard and brittle. Some of the soft side also are there, but hards are also there on the other side. And then there are ceramics are also there. Ceramics machine is one of them, like very hard and needs a very strong tool for them. Then there is a brass, copper, plastics. Plastics, as I said, like 60% of plastics, 40% of glass. Uh, those kind of plastics are called that: nylon, derylene, Teflon, foam, acrylic, carbon, laminate, polycarbonate, etc. Surface treatments such as DI water cleaning, passivation process, electro-nickel plating, etching line, rust prevention, conversion coating, chemical film. These are all kind of surface treatment normally done with machining parts. Okay, so I'm running out of time, so I'll just go a real quick review on this one. These are roundness tester, CMM, vision CMM, contour, X-ray, pressure cooker tester, salt stress tester. These are all used for measurement and testing of the part. Inspection instruments like hardness tester, as I said that. Then spectrum analysis are there. You want to you when you use the material and then you know you break it and then you use the broad spectrum of light to determine that level of materials particle inside or the material presence in that particular uh, specimen that you have given to it. That's the one that is called. And then liquid particle counter is there, round tester, roughness testers are there, vision instruments are there. Like you want to check the counter of the part, then you have to check use the hardness testing tool maker, microscope or profile projector. You can use from a small part, you can see it in a big, and then you can measure also. Then CMM is there, zygo is there. Zygo is to understand the flatness of the part, even though it means 0.00001, uh, not in a micron even, like less than that. Then Z's contra CMM is there. These are measurement equipment like plug gauge, air gauge, height gauge, thread gauge, dial gauge. Might be we have some of them we already read, but then these are all customized made as per the requirement in the industry. So case two is the stamping industry where we are using punching, bending, laser cuttings. Uh, we have fire cutting machines, EDMs, grinding machines, and machining center. These are all used in stamping machine, which is normally varied from 25 to 200 ton. Then there is a laser like YG laser used with the robotics. This is like industry 4.0 concept where industries nowadays are operate based on a remote control. Like example, you have low cost countries, Cambodia and Vietnam. You want to install some sort of machining house, and then you want to control it from US or China or somewhere in India. You can see them working, and the experts can virtually go there with the glass, uh, the virtual glass, and then can fix the part. Like they can see that. Uh, mm, the maintenance actions or something that they need to suggest at real time at the place. This is actually happening here. So it is, and all the data and everything loaded on the cloud, so the customer has the right data and direct access to the data that they wish to have, and people can do the remote control and expert help with the VRs, like as I said, and then easy to determine fault, remote manufacturing, use the AGVS. All this thing could be done with the Industry 4.0 concept. Again, some of the basic certification that has been done with the machining industries: ISO 9001, ISO 14001, ISO 16949, uh, etc. Give me a second. All right. So going further on this one, so state of art, we have observed that machining is not only machining, but it has a wide range of expertise which need various skill. So now, after so many slides we have seen and we have talked about a lot. So see the area that the possibilities that has been involved in this machining center. We need to have a programming, CNC programming, CMM programming skill, Mastercam, SolidWorks analysis, improvement quality tools, SPC, like statistical process control, 8 discipline in the quality, Kaizen, 5S, FMEA, TPM. Some of the people, they are totally doing only one work in one, some of the tooling, some of the machining industry. Like some people are doing just quality tools, they know SPC, 8D, Kaizen, 5S, FMEA, TPM, then GD&T, stack up tolerances analysis, tooling knowledge, machining parameters, feed, cutting speed, material expertise, maintenance tools, PMP, project management, like running through different parts program together in the machining house. Then system integration with PDM, ERP, SAP, business to business things that is also required, along with operation supply chain for various range of materials. Then vendor management inventory, VMI, negotiation skills, supply chain required for this one, industrial norms such as POPR, CO, custom certificate of origin. PO is like purchase order, purchase requisition, conflict material, REACH, ROHS. Those are all like need to understand. OE, overall equipment effectiveness, Lean, Six Sigma, Pareto chart, artificial intelligence, machine learning, enable automation to support industry. See the vast variety of field areas, those are all required to have this effective machining center to run. So I'm just giving a little bit of about FMEA, that is called failure mode and effect analysis. It is used it is used as a quality tool in different system approach or function approach or design, process, services, software, or manufacturing. And it is activities which normally involve a team where uh, the people normally come across and give their ideas and feedback, and then the person who is conducting it, the champion who is conducting it, he's evaluating the potential severity of the failure, like which is the most severe factor that need to be uh, targeted first to be improved or improvised. So FME identifies the fact and outcomes of this failure or action. It is a time-consuming analysis, involves multidiscipline team. So normally applied to the most problematic, expensive process, or when product is new or abrupt failure happened, or when there is a scar from the customer. So this is how the FMEA is very important. Like when it involves a lot of, you know, lot of amount of money or efforts required, when customer has quality issues and there is a failure happen, and those are very expensive kind of stuff. So it's the benefits are improved product process reliability and quality, and increase customer satisfaction, early identification of the failures, elimination of potential failure modes, prioritize the product process deficiencies, capture engineering organization knowledge, emphasize problem prevention, document risk and actions taken to reduce the risk, provide focus for improved testing and development, minimize late changes and associated cost, catalyzed for teamwork and idea exchange between functions. So overall, in every FMEA, when it is DFMEA, design FMEA, process FMEA, SFMEA, we can name whatever the process what we need to have. The main thing is RPM, that is called risk priority number, which is having like severity of a part along with coming with occurrence, like how many times this severity will happen, and then detection. So this multiplication give you an RPM number. RPM number is the one that is being, if it is high, those are only the focus area for the people to improve the process. So if you see the industry norms, it's like select the process, then describe it, identify the potential failure, identify consequences, then identify possible cause, and then bring out the RPN, plan and implement the changes, and result it with the documentation. This is what overall in FME process it happens. Going further, I'm just giving a little bit of research topic where it's still underdeveloped because water jet or abrasive jet machining is one of them, which is like high pressure of jet used with water with microblasting and a small amount of particle inside or big amount of particle inside. And then this process is very expensive nowadays because still, still it is not that accurate, number one, and it's a very time consuming. So it's the research is still going on. You might have already heard about this, but it's not widely used, but it is still there. Depend on the application. Ultrasonic machining, I already told about this. That's again a frequency-based machine. Like we use the frequencies to remove the materials of the from the machining or the workpiece. Uh, Next is the 3D printing. It's a quick topic, and if you see 3D printing, it's one of them very favorite prototype kind of stuff. Prototype because the material still not having very high accuracy, and then if it is needed a quick turnover to find out like how the product will actually look like, then only the 3D printing is used. But 3D printing is not widely used for production. Or laser cutting or plasma cutting. These are still a research topic and still ongoing and underdeveloped. Again, like as I said, it's a multi-billion-dollar industry from Cisco to Tesla. Cisco and Tesla, I've just used as a referencing because everyone knew it because these two giants, they use every now and then the fabrication and manufacturing or CNC machining. So even though the market slowed down, but during this still sluggish market, these are still in demand, and the demand is ongoing still with that. So with a wide variety of position, this machining domain could be perceived, and like wherever which area you wish to go, you wish to go further on that one, and of course the sky is the limit in this one. So however, and then coming core means this is one of the thing that we need to have, and we wish that it could be going further. People will be more and more focusing on machining and fabrication, and also some of the countries which wish to be have a self-reliant kind of attitude, they can pursue uh, machining and fabrication. So I use some of the reference paper, and I this is how I wish to conclude this course, and I wish to take the questions if anyone have anything. Hello.
Hello.
Yeah.
Hey, hi. Thank you very much. Can you hear me?
Yeah, I can hear you. Yeah.
Perfect. Thank you very much for the session.
Thank you.
Students, question and answers like time. So if you have any questions, please drop in the chat box to join the discussion. So meanwhile, we do have a first question for the day. So it's like, what are the few examples of products for of broaching process?
Products.
What are the few examples of products for broaching process?
Example like when you have to cut a big machines in aerospace or the structure or structural industries. Example like a beam you want to cut, okay, and it's a kind of customized beam where the material is very big. You want to have this broaching process to be done. So this is some of them where the material removal rate is very high and the accuracy is not that much high. It may be 100 to 200 micron you can use it. So that is where the broaching operation is being used.
Okay.
Yeah.
The next question is, what is the need of grinding process?
What is that?
What is the need of grinding process?
Oh, okay. So one product is there which have a higher surface finish. Okay, so there are like a few parameters we should know. Number one is the flatness. When we know the GD&T, flatness is there, then parallelism is there, and then there is a surface roughness. Surface roughness. Three parameters are there. So these three parameters need to be met with a product which need to fix it with another product. Like when we have a mating part, one part A mates with the part B, and that needs a very high accuracy, it can go with the grinding process. And then another one is, again, it depends on the complexity of the part, and the part need to be like very flat, then only it can happen. Or maybe some sort of plate which we could use for fixing on one side of the assembly, so that the assembly could be, lying exactly in the place. So to maintain the flatness, parallelism, and surface roughness, we normally use the grinding process, and it's been widely used in the optical industries.
Okay. The next question is, what will be the future of CNC machining in hospitality industry?
Hospitality industry normally uses hospitality industry normally uses the products, those are uh, those are required from the custom oriented uh, contractors. Okay, so example, any hospital industry, you take like suppose a hotel, right? Hotel, you want to have, I'll just give an example, like you want to make a very nice decorative stuff. Okay, so that nice decorative stuff, it looks nice, you can make a 3D print out of it, but then you don't want to buy a 3D printer, you can go to the machine house and saw that, okay, I need like 20 of them, those need to be very nicely, you know, this kind of structure is there, and can you do it a 3D print? That's the one thing. So if you ask about hotel industry, um, it is a very, very, very useful in hotel industry, sorry, hospitalization industry, hospital industry also.
Okay.
Hmm.
The next question is, what are some fabrication applications in manufacturing medical equipments?
Medical equipments.
Yes.
Okay, in medical equipment, suppose you want to make uh, a DNA analyzer example. Okay, so in DNA analyzer, you want to make you should have a cover. The cover is made up of plastic. So what will happen is that you can make that cover with the help of plastic molding, as well as you can make it with machining as well. So when your demand is very high, then you can use a plastic molding process to make the cover. And inside there are covers you can use, there are machining base you can use, then there are support system you can use. So in medical industry, I think about 60% of the items you can use it from the CNC machining stuff.
Okay. Thank you.
Yeah.
The next question is, what is the difference between E Dm and Ebm?
As I said, EDM, like electro discharge machining, it's a spark erosion. Like it creates the spark with the current passing through, and through the tool, it creates the spark, and this spark is being, uh, you know, push that material to flow out, the work from the workpiece to flow out, with the help of, there is a water slurry also going on. So this is called EDM process. And in EBM process, it's a high velocity electrons, those are passing in it. It's not the sparks, but it's the electron generated from the coils, those are there. So the coils generate the electrons. You cannot see that something is passing through, it's an electron. So, but the material is getting removed. So that's the difference between these two.
Okay. So, can you please give some information on composites and some more information on aerospace applications in India?
Okay. See, what happened is that when you make the material, you can use it like a normal material for your product, like aluminum, or you can use sort of like, which is readily available in the market. Okay, but then when it comes to composite, you have to have like your requirement to be specified in the products. Okay, so these composites are special materials which you order to the industry that you wish to make. I'll give an example like powder metallurgy. Powder metallurgy, in this powder metallurgy, you can use a different combination of material inside one material, and you can create your own material. And this material, you want to increase the hardness, but you want to make it less brittle, right? You want to make it more softer on the other part, and you'd like to have more conductivity in it, but you want to reduce something on this one. So your definition to your requirement on the material is what composite is. So this composite give and you have to give it to the material manufacturer, and these are very specialized material you can use in your grade, in your requirement. Okay, so this requirement is to be very specific and given to the material supplier, and they will make it specifically for you. Those are called composite. And then in aeroplane industry or aerospace industry, if you see, the most of the materials those are being used are aluminum based material because of the lightweight, and also uh, aluminum based composites they are using because of the weight and the strength they have to get. Yeah.
So what is meant by zero finishing?
Zero finishing is you want to make tolerance at very lower at minimal level when you wish to have this uh, target on the part, that is called zero finishing. So you have to be like doing a lot of time iteration process of grinding to achieve that. So in layman terms, you can say that zero finishing, or you can give a very specific, uh, like specification, which is very less intolerances. So that time you say it's zero finishing.
Okay. And
Yeah.
so what are some fabrication applications in manufacturing medical? Okay, the same question again. So when should we do heat treatment process, that is before machining or after machining?
Normally, people do the heat treatment process after machining. There is a reason behind that, but before machining also depends on the process. But I'll cover both. Okay, let me tell you. First is like talk about the after machining process. You have We have made a part which you want to increase the hardness. I'm giving one example. Hardness, you have when you bring the norm aluminum, it's like a 55 RC. Okay, but then you want to increase it to 65 or 60 RC. So RC is the scale, right? Rockwell hardness. So when you want to change the hardness level, so you have to send it for the heat treatment. So heat treatment, what will do? It will, for time tested, like time. There is a time based heating in this one, in a particular furnace. They know it, like how long they have to keep it to make it as this much of hardness. Like 4 hours they have to keep it to make it more hardened, so that you can get that level of hardness in your product. So this is called post-process hardness. When you want to increase the hardness, you want to make it more ductile, you want to change the granular shape, you want to change the steel from martensite to artistic, or austenite. Sorry. So those are the things that uh, you can use in the process to make it, uh, like use the hardening process to make it as per your desire. This is in the post process. But pre process, if you want to use a part which came as a raw material, a very ductile, but then you want to change and then machine it so that you can machine it at the beginning to gain the hardness of the part, and you don't want to disturb it after process, so you use it at the pre process and then bring that part and do the machining.
Okay. So how can plastic and glass withstand tensile load broaching process?
Plastics and glass. uh, Plastics normally, plastics are like ABS. Glass plastics are like Ultim, and then glass are itself another one. But then broaching process we normally don't use in this one, because uh, see what happened is that broaching process, again I say it's a wider one because it's having a wider tolerances, right? And it needs a very big tool and broaching stuff. So what happened is that normally I don't see that people are more using broaching process in plastics or glass. I don't see that.
Okay.
Yeah.
And what is meant by OEE?
Overall equipment effectiveness.
Okay, so
Yeah. So
mhm.
what happened is that when in the production area, what you do is you have a machine, right? So you use the machines, uh, and then you use the machine to make the parts like 10 parts. That machine can make in 1 hour 10 parts. But then what happened is that uh, you are getting like 5 parts or maybe 6 parts. So you want to increase that from 5 or 6. So you have to determine first that your overall effectiveness of the machine, how much. So once you get that, suppose your overall machining is just 60%, then you have to increase it. So that is what OEE stands for. So you have to consider some factors in this one to make it increase these factors to a level like 80 or 85% or 90% like that. That's called OEE.
Okay. So in pharma manufacturing, can we use aluminum instead of steel? Uh, yeah, in pharma machine manufacturing.
Which one? What is that?
Okay, can we use aluminum instead of steel in pharma machine manufacturing is the question.
Aluminum and steel have like two different kind of material. We depends on the application. It's based on, the judgment is totally based on your requirement. Yes, because it's a metal, right? But then no, because what happened is that steel is also a machinable item, as well as it has you know the surface structure, the hardness, and it has also what do you call it, but other side aluminum is like ductile and highly stress resistance, like. And but these are like your requirement when you say I can replace this one with that one. Yes, but depends on your purpose. Suppose again one more thing, it's noble, right? Steel is like less conductive, less corrosive. Corrosive in the sense it will not corrode with the time frame, but aluminum will corrode and erode, or it will react with the same circumstances. So that is the reason which area you want to use. It's very dependent on that one. You can use or you cannot use, depends on the requirement of the product.
Yeah. So
Yeah,
which material is widely used for cutting process in manufacturing industry and automation, and why?
I would say aluminum number one, and second is steel. These are the two widely used.
Okay, perfect. So I think we are done with the questions, and thank you very much, John, for
You're welcome.
answering all our questions. And so before just having it like before a wrap up, would you like to add anything else here?
Um, Thank you so much again. But these are one of the thing that everyone, whoever participant are that, because I'm not aware about the participant right now. But if you are in an industry, you wish to start, you are willing to start, and you want to make a self-reliant kind of stuff, machining is one of the very good uh, to start with, machining industry, because of wide application and wide range of possibilities are with them. And also when the world is having like a lot of requirement, and when the world is going through like ups and downs, machining still is a requirement everywhere. So I would say that everyone to pursue a career if it is possible, and there is a very good benefit out of it. So yeah, thanks a lot for listening to me.
Well, thank you very much, John, once again.
Yeah.
So yeah, so you may just log off now, so that like I would like to have a very small interaction with our participants here.
Okay, all right. Yeah, thank you. Yeah.
Yeah, well, participants, thank you very much, everyone, and we appreciate you being here. So I'm just going to share the the feedback poll link. So kindly share your valuable feedback for us so that we can just improve and we can just bring like more interesting sessions like this. So I've shared the feedback poll link. So once it's done, can you just drop yes in the chat box to make sure that you have given your feedback? If it's working, can you please? Okay, so I can understand that it's not working. Just a minute, I'll just share you another one. So you have received one more link. Can you please try that? Can you just share your feedback? Just try sharing your feedback via the link. No, one of my colleague, she has dropped in one more link. Can you just try with that? Okay. Well, thank you very much. So I'm just going to share the certificate link now again. So you can just share all your details, like valid details, to give just your correct credentials to receive a valid certificate. So I've just shared one more link, which is going to be the certificate link. So if you're done filling your details, please drop yes in the chat box. And also, we're just constantly working on leading the way to give you more fascinating courses and sessions on latest technologies and niche areas. So if you have any suggested topics for your upcoming courses, you can just drop an email at satishdesu@skilling.com. Or if you have any queries related to certificates, just drop an email to diana@skilling.com. So you'll just receive all your certificates 7 days after the webinar. I mean, like a week from now. So participants, if you have done filling all the the certificate sheet, so you can just drop a done or yes in the chat box that we can just quickly end the session. Perfect. So thanks for your response. And thanks again for joining us today. And we'll see you during our next webinar. Thank you very much.